Welcome back, and today I'm going to show you about how can a function return more than one values from it. So we're going to talk about pass by references and pass by values. However, before starting talking about pass by references and pass by values, let's just demonstrate these things first. So this one is reference versus values. Okay, reference versus values. So let us just make it simple. Source file, this one. So we're going to declare int x. Okay, then we assign x equal to, let's say, 15. Then what is going on is inside your memory. Okay, so this one inside your memory. Okay, memory of your computer. Then it's going to add some memory location. At some memory location, it's going to reserved 4 bytes, 1 byte, 2 byte, 3 byte, 4 bytes. Okay, it's going to reserve 4 bytes. Let's assume that one cell here is a byte. Okay, at some memory location, it's going to reserve that 4 byte. At what memory locations? Okay, at what memory location you're going to check that memory locations? Print out this one just to check. Okay, memory locations. The slash n of that is percentage ampersand x. Okay, this one is the operand in order to take the memory location of x, and that one is at location of 1.5 megabytes something inside your RAM. So it is somewhere x is in this memory locations. Okay, so it is, let's just directly copy. Okay, x is at this memory locations. Okay, so you're going to have what's going on is if you put x equal to 15, then it's going to assign it, of course it's going to convert 15 into binary format and store into 4 bytes here, but for simplicity we just put 15 here. Okay, then now we're going to make a special thing, which is if you are about to declare a pointer int pointer 1 equal to address of x, means this one is ptr1 is a pointer pointing to variable x by storing the address of variable x over there. Okay, so at some of your memory location somewhere, okay, it's also reserved 4 bytes. Okay, and sorry, this one is only one line, not 2 line. Okay, it's gonna reserve 4 bytes, and this one is used for ptr1. And when you take ptr1, okay, when you take ptr1 equal to these values, okay, this one is what it means is, okay, equal to these values. Okay, what it means is right now this pointer is pointing to, okay, this pointer is now pointing to this memory locations. Okay, and inside here, oh, this was storing 15 before, somehow it was deleted it. Okay, and right now what we're going to do is, if you are going to take int y equal to int y, and if this int y is going to at some other location inside your computer, okay, some other location inside your computer, if you would like to know the location, you just gonna print out its address like this one to now, but we're gonna assume at some other location inside your computer. Okay, you're going to reserve another y variable for at some locations. Okay, and this one is going to reserve that one. Okay, and right now if you assign y equal to x, okay, if you assign y equal to x, so y right now is actually it's not x. It's not this piece of memory. It's still this piece of memory. But if you say y equal to x, it's gonna take the values of this one. I'm gonna make a copy of variable x, and it's going to store inside here. But it is only a copy of the variable x, not x itself. Okay, what does that means here? Not x itself. So right now, if I'm going to change y equal to 18, so y x was, this one I'm gonna print f. Okay, y is d. Okay, then this one is y. Okay, and this one of course is gonna be the same as x, which is gonna be 15. Okay, y is 15. But then when I change y into 18, around printf, okay, y is, okay, and this one is y. But before this, I'm gonna print out changing y into 18. Okay, changing y into 18. Okay, and of course y now is 18. Okay, but the special thing is if you print out x is, okay, x is d slash n, okay, x here, and if you see this one, x is still 15. Okay, x is still 15 even though you change y into 18, because even you say y equal to x, but this one is actually y is going to store values of x. Okay, values of x, not x itself. It's just values of x. So what does that mean, values of x? If you look at the memory here, so y is actually store a copy of x, which is 15. So if you change y into 18, y is 18, but x itself still remains 15. Okay, x itself still remains 15. However, if you use pointer, so if I declare another pointer, okay, this one int pointer number 2, and now I can take a pointer number 2 also point to memory address of x, or you can just say pointer number 2 equal to pointer number 1 is fine. Okay, so what's going on is if you declare int pointer number 2 inside your some location of your memory, some other location of your memory, it's going to reserve for another 4 bytes, 1, 2, 3, 4 bytes. Okay, this one going to reserve for another 4 bytes. Okay, and this at some location, if you would like to know the location, just bring its address. Okay, and when you say ptr2 equal to address of x, from here this one is going to store the address of x. Okay, it's gonna store the address of x. What that means? It means that it is the pointer, okay, pointing to this memory location or pointing to x2. So right now, if you are using pointer 1, you change values of pointer 1 equal to 18. Okay, this one is you going to say changing values, okay, changing values of x using its pointer to 18. Okay, you can use pointer number 1 or pointer number 2. Let's just use pointer number 2 in order to change that values. So right now you're going to changing the values of x. So right now, if you, this one is, if you use asterisk, if you use, this one is pointer number 2, sorry, this one is pointer number 2. If you use asterisk pointer number 2, which means it's going to access to the values of the variable at the far end of the pointer. It's going to access the values of the variable at the far end of the pointer. So this one, so it's going to change x. Okay, so if you change that one to 18, so it's going to change this one into 18 too. So if you use this pointer to change x, then it's gonna be changed to let's make it 19. Don't make it 18 because it's gonna be confusing with this one. So make it 19. So we're gonna make this one 19. Okay, make this one 19. So you're going to print out values of x is now really changed. Okay, really changed x. Okay, and you can print out using values of x using pointer. Values of x using pointer is 1 to access is, okay, this one we're gonna put a new line here. Sorry, we're gonna put a new line here. We're going to put another new line here. This one, PTR1. Okay, you'll see that both of them will get to 19. Okay, you'll see that both of them get into 19. Values of x is 19, and values of x using pointer number 1 is 19. Even though you are using pointer 2 to change it, because what you're changing is you're really changing. Because what you're changing is you really changing x itself. Okay, what you're really changing is you're changing x itself, not just a copy of x or of x stored inside y. And in this y here is you're changing y. But in case of pointer, you are changing x itself. Okay, you are changing x itself in case of pointer. Okay, in case of pointer. And now we're going to create a C program in order to demonstrate about pass by references and pass by value now. Okay, if you understand, let's say if you do y equal to x, that one is copy values of x, not like this. But if you use pointer, then you're going to work with the original variables. Now, let's just make another application. This one is the application next. This one is passed by ref versus by val. Okay, by val versus by self. Okay, passed by val versus by ref. Okay, finish. Okay. Okay, we're going to look at the source file. Then from here, I'm going to make a function. This one is function void chain 1, and this one is gonna change values of a variable, and it's going to print out at the beginning of chain 1 values is, okay, values of a is this one percentage d, this one, and a new line, this one, and I'll put a there. Okay, then I'm gonna print out changing values of a into 1 in function number 1. Okay, and then I'm changing it, so change it into 1. Then of course when I'm printing values of a before exiting chain 1 is this one. Make a new line, this one is a, okay. Then I'm going to declare variable here int x. Okay, and I'm going to assign x equal to let's just make it 20. Okay, no, make it 30. Okay, then from here you are going to call to chain 1 method. Before calling to chain 1 method, you need to declare method chain 1 here. So you're gonna call to chain 1 method to chain x there. Okay, so we're gonna print x before calling to chain 1 is, percentage d slash n here x. And I'm going to call also the value, check the values of, I'm displaying the values of x before calling to chain 1, and also displaying the values of x after calling to chain 1 to see what is the values of x there. So if we execute this application, you'll see x before calling to chain 1 is 30. Of course, it's 30 over there. And then when you print and then when you call to chain 1, okay, when you call to chain 1, it's going to execute chain 1 and int a, and a is going to be a copy of x. Okay, it's going to be a copy of x. So this one is at the beginning of chain 1 values is going to be 30 as well. Then you're going to print out changing values in of a into 1. So you're going to change values of a into 1. So a equal to 1 here, and you're going to display values of a before exiting chain 1 is 1 as well. But then after exiting chain 1, you're going to get out here when you print the x values again, and you get x values is now 30, and it is not changing into 1, even though you was changing a into 1 there. Okay, and you place x in place of a. okay, but the original x is still 30. So if you're changing a there, okay, it's just changing a itself. This one is what it means. If you see from values and reference before, this one is what it means is that it is actually a is actually having a copy of x, not x itself. Okay, so what is going on for this one is, let's just look at memory. We're going to erase this one. Okay, I'm going to delete this one. I'm going to delete this one, and we're going to have our clean memories this way. So there is no merging there. Okay, so now what is going on is, if you run to this one, okay, in x equals 30, so at some memory location it's going to reserve 4 bytes, okay, and that 4 bytes is for x variable. At some location it's reserved 4 bytes there, and for this 4 bytes, okay, 1 2 3 4, okay, it is used to store the values, which is 30, okay, which is 30 at some memory location. At some memory location, again, what memory location, you can just bring it out and see. Then when you display x before calling to chain 1, for sure is 30, because x now is 30. Then when you call the chain 1 here, what happened is you declaring another input variable, which is int a. Okay, so at some other location inside the memory, this one is going to reserve another 4 bytes for a here, another 4 bytes for a. Okay, and when you call to chain 1 of x, okay, so a now is gonna have a copy of x. So a now is going to store the copy of x, which is 30. Okay, that is the reason why at the beginning of chain 1, values of a is, and your display is gonna get you 30 here. Okay, then changing a into 1, a equal to 1. If a equal to 1 here, it's going to show you 1, and it's changing 1 here. Then, of course, when you display values of a before exiting chain 1 is, of course, it's going to get you 1. This one is, so x is 30. At the beginning, a is 30. Changing to 1, and values of values of a before exiting chain 1 is 1. This one value of a. However, the values of x is still there. Values of x is still there, 30. That's why after finishing this chain 1 method and you try to bring x out, it is still 30. X is still 30. Okay, x is still 30. So now I'm going to make another method, which is void chain 2. Okay, and instead of passing the copy of values of x into variable a, I'm going to pass in the address of, or I'm going to pass in pointer of x, or its address of x in. So this one, we need to pass a pointer of x, which is pointer b. Okay, pointer b. So right now we're going to say print at the beginning of chain 1, values of x is, percentage d. This one, you're going to put this, in order to access the values of a variable, of a pointer, you're going to put b here. Okay, this one is to say it is values of a variable at the far end of the pointer it is pointing to. Okay, pointer b in this case, and pointer b later on gonna point to x or y is fine. Then right now, if this one is chain 1, let's just assume we're going to modify another similar variable int y equal to 30. Let me make it y, because I don't want to mess up with this x. I want to make something which is similar to x but y to compare the differences. Okay, then right now we're going to print f as well. We're going to changing values of variable using this pointer to 1. Okay, so you're going to take the values of b equal to 1. Right now you print out values of the variable at the far end of b, okay, or in this case y is, okay, percentage d slash n, and this one is values b. Okay, and then right now we're going to call this method. I'm going to call chain2, and I'm going to change in order to instead of passing the copy of y, I'm going to pass in the address of y. Okay, why address of y? Because this one is actually a pointer b. So I'm going to print this one similar, print f. Okay, y before calling to chain2 is percentage d slash n, and if you put here y, it is 30. And when you call to chain 1 after that, you're going to call to y after calling to chain 2 is. Okay, so if you run this, it's similar to this one with the modification of x using chain 1, and this one is modification of y using chain 2. And passing to chain 1 is you're passing a copy of x into a, but passing into chain 2 is you're giving the address of y into chain 2. And what is going on is you'll see I forgot to declare this method on top. Okay, so I need to declare this method. Okay, so if you execute this one, and you'll see, so for y before, okay, y before calling to chain 2 is 30, but at the beginning of chain 1 the values of y is 30. Okay, is 30 too. So this one at the beginning of one chain 1 at the beginning of chain, sorry, this one is supposed to be chain 2. Okay, this one's supposed to be chain 2. Okay, so you can see for x I already explained. Now for y, okay, now for y before calling to chain 2, of course it is 30. So what's going on is if this one is int, you declare int y equal to 30, in some memory locations inside here, in some memory location it's gonna reserve 4 bytes, okay, for a variable y, and this one is going to store the values which is 30, just like x over there, just like x over here. But then when you that's why when you call to y before calling to chain 2 is, of course, it's going to display 30. Now when you call to chain 2, you're going to create another pointer b at some memory location. So at some other memory locations here, it's going to reserve 4 bytes for that pointers. Okay, reserve 4 bytes for that pointers. This is pointer b. Okay, pointer b. For this pointer b, it is going to store the memory address of y. Okay, this one is loc y, means location of y. This one should store loc y there, which means this one is a pointer. It's going to point to variable y. Okay, so what you pass in the method is actually you pass in the address of, or the pointer pointing to variable y there. So now at the beginning of chain 2, values of y is using the asterisk b, access to the pointer. So asterisk b, okay, asterisk b is access to the values of the variable that this is pointing to. So access to y, it is 30. So you're going to have this line going to display 30. So you're going to have this one is at the beginning of chain 2, it is 30. Then right now you're going to print changing the values of variable using pointer to 1. So this one you're changing is going to display this line. Then if you really change it, you take the values of variable at the far end of pointer b equal to 1. So what is going on is that this one is asterisk is going to point to the variable at the far end of b. So it's going to change that value, change this value into 1. So it's really changed this value into 1. Okay, so now you print out values of the variable at the far end b is, okay, this one I'm gonna say before exiting. This one is before exiting. Okay, is. So it's going to display that values is now, values at the far end is 1, because it's already changed into 1 here. Okay, and then this one is you exit the method. After exiting the method, it's going to finish this method. It's going to call to while after calling to chain 2 is. Okay, while after calling to chain 2 is, and you'll see the while from here already chained into 1. Already chained to 1. So while after calling to chain 2 is 1. So you'll see from here the difference between the two is. The difference between the two is if you call to this one is if you call to chain 1 in the scope of chain 1 method. Okay, if you call to chain 1 x, this one is going to give a copy of x to a variable a, means it's going to have a copy of values x to variable a like this, 30, 30. Okay, but when you chain a into 1, okay, that one is only a chain. When you finish the chain method and you get back to the main method, x itself still 30. X itself is still 30. Okay, but in case of you are giving the address of location y, so at first y equals to 30. Okay, in the scope of chain, let's say in scope of chain 2 here, chain 2 is gonna pass in the address of x into here. Okay, it's gonna pass in address of x into this one, sorry, address of y. Okay, address of y, or it's gonna pass in the location of y into this variable. So if you use inside that method, if you use the pointer to change the values, if you use the pointer to change the values on accessor values, it's actually going to change the original var itself. Okay, the original var itself. So after finishing chain 2, the values of var itself is already changed. Okay, it's already changed. It's different from the other case. It's a copy of the variable x. So if you change in local, in the scope of chain 1, if you change values of it into 1, it's not changing the values x there. But in the scope of chain 2, because you're giving the address of y, so that when you use that pointer to change the values, it's gonna change the values from original values of y itself. So this one is a difference between chain by pass by reference and pass by value into a method. If you pass like normal input parameters like this, and this variable is just a copy of x, just a copy of x. So this one I pass by values. A only contain the values of x, not x itself. So you can do whatever with a here. It will not affect the original x after finishing the methods. But in this case, it's a pointer pointing to the variables. This one is passed by reference. So instead of giving the copy inside the method of the variable inside the method, you're giving its address. So you can use a pointer to change the values so that the original values itself will be changed. Okay, and if you're using this one, you can pass more than one values out from a function. You can pass more than one values out from a function. This one is called sorry, where this one now, yes, no, what is that? Common way to working arrange string can run this one can return more than one values from a function outside, because this one, see, you can just pass that variables inside here. Okay, then if you change the values of this pointer, the variable outside going to be changed too, so you're gonna be able to pass that values outside. Okay, beside the return statements. Okay, that is it about pass by references and pass by values. In next session, I'm going to talk about memory allocations using pointer.